do question 2. Given this geometric series of x plus 90 plus 81 plus up to infinity, 2.1 says that we must calculate the value of x, right, of this geometric series. So knowing very well that we have a sequence of x plus 90 plus 81, and we know that this is a geometric series, right? So the first thing we're going to do is we're going to identify the constant ratio, because we want to identify this value of x here. So for us to do that, we need to use the constant ratio formula, right? So if this is term number 1 and this is term number 2 and this is term number 3, then the constant ratio would be T2 divided by T1 is equals to T3 divided by T2, whereby T2 is equals to 90 divided by T1, which is x, equals to T3, which is 81 divided by 90. And then we're just going to cross multiply, so because we have 90 divided by x equals to 81 over 90, so we're just going to cross multiply, and we have 90 times 90 equals to 81 times x, and divide by 81 both sides. So x is equals to 90 times 90 divided by 81. So you can punch this in your calculator. You should get a value of x of 100. So this is the value of x of this question here. We're going to do 2.2, which says that show that the sum of the first n terms is equals to 1000 into 1. So here it's supposed to be plus 1000 into 1 plus into 0.9 all to the power of n, and then close bracket. So we need to prove that the sum of this geometric series is equals to this term here. So we are required to prove that Sn is equals to 1000 into 1 minus 0.9 to the power of n, right? Yes, it's supposed to be minus and not plus. Let me correct myself. It's supposed to be minus. Okay, so what we're going to do is, for us to prove this, we know very well that in our sequence, in our geometric sequence, r is equals to 0.9, and our sequence is equals to a into 1 minus r to the power of n divided by 1 minus r, right? So we need to identify the value of a, of which x is equals to 100, which is the value of a. So basically means a is equals to 100. So we can substitute that 100 into the equation. We have 1 minus into 0.9 to the power of n divided by 1 minus 0.9. So you're going to get 100 into 1 minus 0.9 to the power of n divided by 0.1. So if you divide 100 with 0.1, you're going to get 1000. So it's going to be 1000 into 1 minus 0.9 all to the power of n. So this is the sum of n terms. Now we're going to do 2.3, which says that hence otherwise calculate the sum to infinity of the series. So for us to calculate the sum to infinity, we know the equation sum to infinity is equals to a over 1 minus r, of which our a value is equals to 100 and our r is equals to 0.9. So the sum to infinity would be equals to 100 divided by 1 minus 0.9, which is equals to 100 divided by 0.1, giving us 1000. So this is the sum to infinity. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.